Okay, good morning. This is our class for the Git, Docker, Cloud, and Linux, and I'm Cheng Wei. So in this class, we are going to talk about shell script and Linux. That is the topics of the first week, and in the second week, we are going to talk about the Git, which is a popular tool for version controlling, and for the third week, we are going to talk about Docker and more advanced remote tools in command line, such as SSH and maybe Tmux and other tools that I think they are going to be useful. So first of all, why do we even need this class? The reason is that people come from different background when they first encounter data science or machine learning. So you may or may not familiar with the command line tools in Linux. Some of you may be just a beginner for using Linux. And even if you are using Linux, you are probably much familiar or comfortable with the GUI, that is a graphic user interface, GUI GUI tools. However, when using the tools for development or doing research, times you are going to encounter the usage of the command line tools or command line interface. So it might be a good idea to prepare you with these skills and tools so that you can comfortable with them. So we're taking a slow pace, walking you through this journey to enjoy the command tools. I hope that in the end of this mini course, you are going to feeling comfortable and can enjoy these tools and without being intimidated by these tools. Okay, so this is the first week. We're going to mainly talk about the shell and Linux tools. Okay. So there are two parts. First part is that we're going to walk you through what is a terminal and how to type the commands in the terminal screen. And the second part is that we're going to let you familiar with the concept of what is a Linux, what is a terminal, what is a command line, all those fundamental things. So before that, let's first check the results that appears on our course website. So first of all, the URL, the link to our course website is sh.tjwei.tw. So after typing this URL in your browser, you'll be going to redirect to the website, which is maintained by the Notion. So it contains a lot of information. So it might be just looks like this one. So you can see that it will have the URL to the live streaming, and on the second, which is important, this is a Slido link. Slido is a service that allows you to ask questions online because we are proceeding this mini course online and doing it by streaming. So in nature, it lacks the interactive part for a live course. However, we are using a Slido so that you can have a feedback like asking questions or other comments. Just feel free to do that, and you can do it anonymously. if you are not afraid to show your identity, or you are not the privacy is not your concern, you can also type the comment or feedback on the YouTube channel. But I probably will check the Slido first. So if you have any question, you can use this Slido as an interface to represent your opinion or feedbacks. It also contains a lot of different resources that is related to this class. So one of them is the I listed it right here. There are many different links that related to the first week, the course of first week and the following weeks. One of the most related resource is the missing semester of your CS education. This is a course, a 4-semester course of taught in MIT. The link will lead you to the 2022 class. It has taught many years, I believe. I'm not sure it's still teaching. They are still teaching this class. They're still giving this class in 2023 or 24. But so I haven't checked it for a while. But by leading to this link, you will see the web page of this MIT course. It contains a lot of videos. So feel free to use these videos on this website, the lecture videos on the website and the materials on this website. Because this one is a famous lecture, a famous course. So a lot of volunteers doing the translation for this course materials, including traditional Chinese, simplified Chinese, I believe Japanese, Koreans, and all other languages as well. Like I don't remember how many, but maybe like 10 or 8, 10 or 12, something about that. It includes a lot of topics, but I think a lot of topics are corresponded or interlap to our mini course. Of course, our mini course have less hours than it because it is a full semester course, but we share the same goal and motivation because as my observation that we are kind of overseeing these important things like command line tools, like how Git works or how Docker works, or like how SSH works, the secure share works, because we are so familiar with it, and we think these are just fundamental and too technical and basic tools. We should teach something like data science, machine learning, AI instead. But I believe a lot of you sort of lacking this training or experience. Maybe I should just say experience. Because back to the time that I was learning computer science, learning these materials are sort of nature, because I am experiencing the birth of some of these softwares like Git or like Docker. So when they just introduced to the public view, the eyes of public, they are becoming trending and become the hot topics in the computer science or computer IT industrial. So we got a chance to try them at the beginning and to learn them. And even back to the 90s or 80s, the command line is probably the most practical way for us to accessing the computer. So we don't we are not going to miss this chance to learn it because we have to learn it. However, as the times pass by and beginning, which I think is a good thing, computer is getting easier and easier to use. So it's not your fault, but you are lacking of the chance to learn. In some situations you probably doesn't have any chance to learn it. So it's not your fault, but we kind of overlooking it. So it's a good idea to put this material back in the regular semester course so that you can actually get a training for this one. And it is also a good thing that we are in an era that we're going to AI. And in fact, AI are more it makes the command line things more interesting, which I will point out this a little bit later. But before that, let me show you another resource that is contained in the web course that we have the link, which is the Linux Shell crash course. So this one is a crash course that helps you to learn the Linux command in a more organized material way. To do that, so you can learn these materials in less short, organized learning materials. So if you are really into it, so maybe you can visit this website and have a quick look at all of those things. But however, I think if you wish to learn a sense, a more natural or more robust and stable way to learn things, to make the memory more stable way, is to just have a journey and enjoy it. So whenever you are seeing the things along your journey, you are going to memorize it because they are kind of more related to you. So just relax and enjoy these things. And also there are a homework assignment that appears on the course website. In this mini course, we are going to have some hand-on labs, and you are going to have a lot of things you may want to try on your computer. But we only have one homework assignment. That is for the second week for the Git, because there are website that teaching the fundamental of Git. Although people may learn Git in a more practical way that just try a few commands and building up experience. But there's actually a core logic behind the Git operations. So for that homework, you are going through a few practice that help you to build a foundation to understand the logic of Git. We're going to talk more in the next week about that. Okay, so why command line? Okay, there should be a picture right here, but it is not. I'm using Canvas as my sliding, so sometimes the Canvas does not load the image well. Let me try to reload this image again. I am not sure. Okay, it should working right here. Okay, let me show this side. Okay, this is just a fast food restaurant. So when I'm using this image is to emphasize the difference and the usefulness of the command line tools. So I usually compare the command line tools with the GUI in this example. So GUI is quite useful in a lot of places when it is useful. So an analogy is that when you go to a restaurant, you can order things quite easily. Like, okay, if I'm going to a fast food restaurant, they probably will offer some combos, like combo number 1, number 2, number 3, number 4. So if what you are going to choose is one of the combo, then the order is quite easy, because you can just go to there, say, okay, I want combo 9, combo number 7, and for drink, probably I want some Coke or maybe other like black tea or some other thing, and maybe I will change the fries with other like chicken nuggets or something else. That will make things quick and easy. You can just point out. In fact, in this situation, you can just point out. In a lot of fast food restaurant recently, you can order things on a screen. That's kind of support my point, because everything you can just point out and select. So in this case, the GUI or graphic user interface is totally useful and suitable. However, in sometimes you wish to order something that more special, you need a hidden menu, a special chef menu, and it is not on the menu. You have to describe your need. I don't want onion. I want more, maybe ketchup, more cheese. Like how much the cheese you want, and maybe I want the drink to be a mix up of Coke or Sprite or black tea. That doesn't make you the most favorable customer. But I mean, if that is what you want, and if you want to express yourself, you probably cannot do it on a GUI or using your hand to point out things. You have to use your language to express it. So that's why that's kind of similar to the situation when we want to use the command line. So sometimes it is very difficult to design a user interface, a graphical user interface that has all the functionalities. However, for a command line, it's just kind of like a language. So you can have more expressive powers to what you are going to need. And over time, you are going to see this sort of things. In nowadays, it is easier to explain this idea to you, because, okay, even before that AI or like ChatGPT is popular, I have to give some analogy that we still use language, speaking or writing to communicate to each other, not just drawing pictures. I can use that, but a more precise analogy is ChatGPT, because ChatGPT is actually pretty similar to what command line is. You type something, and you get a feedback, and you type some sentence again to give your order or your request. So command line is just like ChatGPT, except it is not that smart, because we don't have that technology before. So we have to use some more formal syntax, more strict syntax that you have to learn and follow some format. So of course, ideally, we want to just talk to a computer and get response. The ChatGPT, I mean, it's not there yet, but a perfect ChatGPT or ideal ChatGPT is what we are looking for. But before the AI, ChatGPT style AI has been invented, we have to go for the most similar thing to this idea is the command line. So you may imagine that why don't we combine the AI with the command line together? In fact, we are doing this. We are still doing explorations and study and experiments, but people are already doing that. So I think command line is still relevant more than ever and it's going to be more and more relevant because of the AI. And in a recent future, I don't know how far or near, but in the future, maybe we are going to see some revitalization of the command line user interface. One thing that shows the similarity between the chat AI and the command line is both of them use a word called prompt, a prompt. You are going to see that in a command line, in a terminal, we are seeing a prompt. And of course, we are using this terminal prompt to say that our command or conversation or input to the AI as well. So now let me list a few shells that is commonly used. And then I will going to give you a record video that I have recorded yesterday and show you some usage of the terminals. I won't play it for the full length. I probably will play it for like probably 1 hour, to show you how the feeling and some basic concept of the command line interface and the Linux system. The full video you can find on YouTube as well. And after I've recording the video, I have feeling that 3 hours is not enough because we also have a Git and SSH need to cover. So I probably will going to record more video as supplement materials to this course. But just in a while, like 5 minutes later, I'm going to play the video so that you can see the how the terminal kind of seeing it works. It won't cover anything, but it will give if you are a very beginner to this type of thing, it will give you some idea. And I'm going along the way, I'm going to explain some details about like file systems and some basic concept about command line. But right now, I'm going to show you a few shells that people use. The most popular shells is probably the Bash. And ZSH and the Fish are also very popular among the developers because they are more modern. But Bash is the standard. It's probably the first shell you're going to see when you log in, when you install a new Linux system. And I believe that in the Mac, you probably should see the ZSH. And the Fish is another friendly, as the name suggests, it is a friendly interactive shell. But ZSH and the Fish are more modern. And the Bash is come from a long time ago, have a long way to here. But all of them are really popular. Currently, Bash probably the most popular one because it is default installed on the Linux. Other shells you might see is the vanilla SH. SH can be considered as the you will see it in almost every system because it's considered as the simple shell, the most core shell or simple shell. Although its functionality is not as well as Bash, because Bash can be considered as a more functional, complete, a more advanced SH, but SH still considered as a standard. So you will see that in a lot of places, in some small system, you probably are going to use this version of shell. But SH and Bash are sort of like in the same bloodline. You probably can see from the name because this is a Bonon again shell, and this one is a Bonon shell. So that is a successor of this shell. But both of them are pretty similar for the core syntax. Another family of shell is CSH and the TCSH. TCSH and the CSH, the relation between TCSH and the CSH is sort of like SH and the bash. So TCSH is a more advanced one. The difference between CSH and the SH is that the C shell has a syntax more like C language, because a lot of people like C language. However, you probably are rare to see this in nowadays, except if you are using like a BSD style operating system. So you are still going to see that. A lot of people back in 90s prefer this shell, probably including myself, because I'm used to writing the program in C language. So C shell makes more sense. But as the time goes and I use Linux a lot, the bash is becoming my more comfortable shells than CSH. I probably forget all the syntax of CSH as well, but they are less common to see nowadays. And in Windows, they also have some shells, but I'm not going to talk it right now. I'll go talk about it later. So for now, let me switch to the pre-recorded video so that I can show you some basic and introduce you how to do your experiment and learning for the command line tools on your computer. So let's go to that video. Next, I'm going to introduce the basic command line tools and the concepts listed in our course website in this section. These tools are more towards the fundamental and the basic tools. We also maintain a list of more modern, more edgy, more newish tool near the bottom of our course website, right here. But right now, we are going to first introduce the more basic or essential tools. Before we introduce these tools, let me first show you a few ways to access to the command line interface. One of the easiest way to do that is using Colab. If you have a subscription to the Colab, then it has an icon, a terminal icon near the bottom left side. So if you press this icon, then you'll get a terminal right here. So you can do all the terminal commands. Another way to do that is to use your system's terminal. If you are using Linux, you just search for a terminal app, then you will find one. No matter you are using a GNOME desktop or using a KDE desktop environment, they all provide some applications that works as a terminal. The same thing is true for Mac. Mac also comes with a terminal. You can also install other terminal applications, some third-party terminal applications, if you prefer. Okay, in Windows, things got a little bit difficult, more complicated, because by default, Windows does not have a Unix or Linux-like environment. So there are two ways to get one. So one way is to install the Git bash. When you install Git, Windows version of Git, you will get a bash, B-A-S-H. Bash is a shell. That is very popular one. So after you install the Git with Git bash, then you can use your Windows Terminal app to open a new terminal, a new window that has a bash environment. I'm not using Git bash, although I also installed the Git and it comes with a bash. But in this computer, although it is a Windows, I'm using a more complicated setting. So I'm installing MSYS2, which can be considered as a more complicated or more complete version of the Git bash. It comes with a lot of tools and has its own package manager to install things. But as you can see, it looks like a terminal the bash interface. So I'm actually using bash right now. So it is a bash running on Windows. I'm not sure. I didn't install ZSH here. Another way to access to a full Linux environment is to install WSL, Windows Subsystem Linux. After you install the Windows Subsystem Linux, right now you probably can install it from the App Store, Microsoft App Store. I forgot Microsoft Store. The Microsoft Store. You can find the Linux or Ubuntu. Just install it, then it will automatically appear in your terminal options. So right here, this Ubuntu is exactly the Linux system running inside the Windows. Compared to the Git bash or MSYS2, this one is a fully Linux system. The Git bash is actually a shell that runs on Windows, provides some compatibility layer to the Linux, but itself is still Windows. However, WSL or Windows Subsystem Linux is a fully it's just a full Linux. It still has some difference to the native Linux system, but they are close enough. So here, I think I'm running a ZSH. No, a lot of my system running ZSH, but this one is still running bash, which is good because I think for the educational purpose, introducing bash is better because it is more basic and sort of more fundamental, and I think it is still much popular than ZSH in the sense that how many machines are installed with it. But a lot of developers prefer some newer shell like ZSH or Fish or maybe a few others. But bash is still considered as a standard. Okay, another way to access to these shells is using Visual Studio Code, and this is what I'm going to use. If you are running it on a Linux machine or on a Mac machine, you can use it to open a shell by compressing Control backtick. So you can have a terminal right here. This is a terminal emulator and running a shell right here. If you are on a Windows, you can still use VS Code as your terminal emulator. It just you still need to install the WSL or the bash, or you have to use SSH to connect to a remote machine. And VS Code allows you to do that by using the remote Explorer. Okay, so right now I'm connect to my WSL, Windows Subsystem Linux. The reason that I'm going to use VS Code as my terminal emulator is because I can use Copilot chat right here. You can also use Cursor. Cursor is famous for its AI capability. However, in my experience on the terminal use on Windows, it has an issue. I believe it is probably my fault because I'm not that familiar with Cursor. But the thing is, one of the very common function I use is to use Control-L to clear a screen. So let me first list the files, which I will go into detail just a moment. But just let me fill the screen with something. Maybe I use find. So one very easy way to clear up the screen, the terminal screen, is to press the key Control and L together. When I do so, I clear the screen and I can go to the top to the top row and run my other command again, like this one or other thing. However, on Windows, and when we use Cursor, the Control-L is going to call the pop-up of the AI assistant. So because Cursor has a lot of AI functionalities, so kind of like the chat, but it has more ways to call up the AI assistant. One way is to use the shortcut Control-L, so the same shortcut. It works pretty well when you're editing the Python files or C++ files or other files. But in the use of terminal, I find myself often press the shortcut Control-L when I try to clear the screen. But it doesn't achieve, of course, it doesn't achieve the result I was expected, because it just the pop-up, the AI pop-up just show up. Of course, I can use like clear to clear a screen using a command, but I'm so used to this shortcut, so it's kind of a little bit of trouble. But aside from that one inconvenience, and probably that was my fault, but aside from that inconvenience, you can use the cursor as well, and you will have AI assistance just in your hand, and maybe even easier. Okay, so but this is my setting. I'm using VS Code and I'm using the GitHub Pilot chat on the left side so that I can ask the questions when I'm not fully sure what I'm doing or when I get confused. Because there are a lot of different options and command for each tools, which I'm not aware of. I'm going to go to that part just a bit later, but I'm just explaining the reason I'm using the VS Code as my terminal. There are some drawbacks for using VS Code as a terminal. One drawback is VS Code is kind of slow, but there are also some advantage of the when you use VS Code as your terminal. One advantage is, of course, the major advantage here is that I can use GitHub Copilot right here, and I think it is a good way. And if you are not you are a beginner, I encourage you to do the same, because GitHub Copilot has an educational. You can use the educational version for free, as long as you are a student or a faculty for in a college or in any other schools. So why not use it? It is useful. Some people prefer Cursor AI more, and arguably Cursor AI is better. But as a student, you can use it for free. So that's one settings you can consider. Okay, so let's walk through the commands that list in the course website. So I'm opening a window in another monitor to see the command, because they are ordered in some sense. Okay, first we are going to the most basic commands that you should use it to survive in the command line. The most basic command is cd, which means cd change dir, change directory. A directory is kind of like a folder, if you are familiar with the terminology in Windows. So okay, okay, never mind these commands. I'm just trying to install a command so that you can visualize the directory structure of a file system in Linux. In Linux, it always has a file system. It kind of like a tree. Let me go to the root. So okay, it's just too big. So I'm giving you an example to using Copilot here. How do I use tree command to list files, list the directories? Okay, so I want to limit the recursive depth of tree. So I just ask a question here, and it gives me a suggestion that using the option -arrow3 to limit the recurrence search depth of the tree. So I'm using this button to insert this command into my command line. Into my command line here. Okay, let me Control L it again so that you can see it more clearly on the top. Then I run this thing. There's still too many levels. Let me just make it like one. Okay, so the file system is like a tree, mostly like a tree. Technically, it is not a tree, but in most of cases, it is close enough to a tree. So we have a root directory, and we have many subdirectory and files on this root, and each subfolders or subdirectories, you can have a subdirectory of its own. Each subdirectory can contain some files and subdirectory of its own. So basically, it is a tree structure, kind of like it's not that different with the file system in Windows. except Windows has a C drive, a D drive, or other E drive. But in Linux file system, or other Unix file system, it has only one root. It doesn't have other drives. It just has one root. So if you have another, say you have two hard disks or some SD, then how do you access to them? In the file system of Linux, you mount this drive to a subdirectory. So the root is probably lives in a partition of a hard disk. When I say hard disk, it might be referred to the solid state disk, but I'm just calling it hard disk, or maybe I just call it a disk. So the file system in a PC or in a computer, usually we bought a disk, either a solid state disk or a hard disk. Then we make partitions to separate this hard disk into some subspace. And each partition is kind of like logically like a drive in the Windows system. So in Windows, you can just put one hard disk and put it into your computer and run the partition tools. Then you get two drives. And maybe you can get another solid state drive, solid state disk, and making like 2 or 3 partitions, and each of them is logically considered as a drive if we are using the terminology in Windows. So in Linux, the root file system, the root lives in one of the partition or in one of the drive. Other drives or other partitions can be mounted as a subdirectory in the file system. So that's a logic. But logically, your file system just looks like a tree. So we can use some command to see where we are. One command is pwd. So currently you can see that I'm at the root directory. So we just got a slash right here. So which means root directory. And I can go to my home. I can use the cd with any argument. I will go to my home directory. Then I use pwd to see where I am. So I'm in home tjw. So that means I am in a top level subdirectory home. And in the home directory, there are many different subdirectories. But I'm in a subdirectory or subfolder tjw of the home directory. So you can see we can use this command to just navigate through different part of the system. So I can give an argument of the full path name, like home. Then I'm going to the home. So you can see the prompt here gives you a hint of where you are. This can be set in your system environment or in your home environment, but this behavior can be changed. But this one is a popular setting, so that because we usually we know where we are before we can do any other command or things. Otherwise, it would be very confusing or dangerous. But no matter what, you can use the command pwd to see where you are. See, I'm in the home top level subdirectory home. I can use ls to see what folders or what files are inside in the current directory. So you see, it only has one subfolder, which called the TJW. Then I can change to this subdirectory. As we have mentioned, we can simply type cd because home/tjw is my home directory. So in order to make things more convenient, I can go to my home directory by just using a cd command without any argument. However, there are many different ways to access to this subdirectory. One is just like before, we give full path name, then we go to the home directory, and you can see that it shows a tilde right here, because the tilde usually means just a shorthand for the home directory. So I can also use cd tilde. I'll go to the home directory. Let me go to root directory first to show you this actually works. So you can see it becomes tilde right here. Also, I will explain the dot later. Also, if I am in the home directory, I can use cd tjw to go to the subdirectory. This is called the relative path. So without using giving the slash, so I can just simply give the file name tjw. Because currently I'm in home. So tjw means the files that in the current, the folder name in the current directory. So I don't need to type the full name. I simply type the tjw is enough. So it makes things easier. So let me see how many files are in my directory. If I use ls is to list the files here. Then you can see that I only have an output.json and src subdirectory. You probably can find the difference between these two file names. One is blue and the other one is white. This is because we can set some color scheme to the files that list with ls, and in this case, the blue happens to be the directory, and the white characters happens to be the regular file, just a regular file. So I can easily tell which is a directory and which is a regular file. But this coloring is not universal, because this is just my setting, which is sort of a default setting because I didn't change it much. I didn't use my WSL much. I use Docker inside the WSL to run some service, but I rarely touch the files in my Windows subsystem Linux recently, so you didn't see many files in this system. So I believe this one is default settings. However, it is not reliable because everybody can change this coloring scheme. So is there another way to more reliable to actually see the file properties? There's one way to do so. You can use ls-l. -l meaning I forgot the meaning, but it means more detail. But using more detailed things to see it, to see more detail. So let me explain what is here. So these numbers right here is the size of this file. For a regular file, this number is exactly the size of this file, how many bytes it contains. So what about SRC? SRC is a folder. Why does folder even need a size? Because a folder still needs to store some information. If you need to store some information, then it will occupy some space in the disk. So it indicates how many space is used by this SRC, the SRC subdirectory. Because in this subdirectory, it doesn't have many files in it. So this size 4K is the is a minima, probably the minima size allocate for a folder. If I put many files in this subdirectory, this size will getting bigger. But right now, let me use as SRC. You can see there's only one subdirectory inside SRC. So this 4K is probably just the minimum requirement to allocate a folder. Okay, usually you don't need to worry too much about this number if it is a folder. But it comes time that you will find this might be useful, because you can probably guess the efficiency of the file system if you see this one is too large. Okay, then what does these two means? TJW and TJW. The first TJW means the owner of this file or this folder. That means the user TJW, which is myself, owns this file. So other people does not have the fully access to these files. So some access can be only done by the owner. And the second TJW is the group. A group can contain more than one user, and a user can be a member of different groups. But the second TJW means we have a group called TJW. It is automatically created when we create a new user in Linux. So each user has a group of his own. But we also have other groups like a Docker group or other like the sudo group, which has different meanings. But here it means these files belong to the owner, the user TJW, and belong to the group TJW. This means the last modified time of this file, and of course this is the file name. So how about this mystic characters at the beginning of this file? This is a representation of the property and access control of this file. You can see that the first letter D means it is a directory, and we have a dash right here. It says that it is just a regular file. There are other characters in the first place. Sometimes it can be a L, which means a link, or maybe a S, which means sudo. But in the most case, you will see a regular file or a directory. And The next three characters are RWX. We in fact have three sets of RWX. You can see that we have R-X, R-X, and RWX. The first RWX corresponded to the user of this file, the owner of this file. And the second set of three character RWX corresponded to the group of the file. And the last three RWX is corresponded to every other users that is not in a group or not the owner. So you can see that RWX here means I can myself can read this file, can write to this file, and X has different meaning for folders and for regular file. For regular files, it means it is executable files like a program that you can run. In fact, a lot of different command line tools are a program. So given the X access, then these files can be run as program files, as executable files in terminology. So this is for the security reason, because we don't want the user to run too many different things, or we don't want the user to accidentally to run some things, run a file that is not supposed to be treated as executable, because hackers will have a more easy life if every file can be executable. So by marking a file that is not executable, it can prevent us to mistakenly running a file. Okay. For a folder, the X means we can enter this directory or enter this file folders by using the command cd, or using any other ways to change our directory, change our location to this directory. If it doesn't have this X, then we cannot go inside this directory. If it has a R access, then it means we can list the files inside this directory. And when we have a W access write, then it means we can create a new file or delete files inside this directory. Okay, so we have basically this is a kind of ancient or primitive access control, but it is still quite relevant and useful. In more modern Linux or in Windows, they actually has a more advanced access control system, more refined, the more precise controllable, and has a lot of more functionality. But a lot of systems still respect to this simple or primary type of access control. So at least when we're using LS, we can still get this the access right of these files. But in some more secure or modern system, although they might still have the same like you can see the same thing, but they may surprise you because underneath they have another access control system. But I mean, in most of the case, this still apply and very useful. So now you know how to make things secure or make things more to control the access right and separate it to, so that one user can access it and the others cannot. So one of the example and you may encounter is for the SSH setting. Okay, so before that, let me give you some more some more argument and options for LS. One option is H. If you use the H options, H means human readable, human. So you can see that the file size becomes like 280K, and this one is 4.0K. This one is more human readable comparing to this long number. So if it is getting bigger, it will have like a mega or giga, so you can easier read the size. Another useful option is LAH. Okay, let me do it again to see what happens. If I'm just using ls-l, you see this directory seems rather clean, has nothing inside this directory. But if I'm using SLA, then you see, okay, there are a lot of files. There are in fact a lot of files in this directory, just we didn't saw it. We didn't see it. The reason is in the Unix file system, but in particular Linux uses it. In the Unix file system, it is a convention that if a file name starts from dot, then it is considered to be some kind of special. In most of the cases, it means this file is a hidden file. Or why does it require to be hidden? It is because it is sort of important or has some meta information inside it. So you can see that we have a cache file, a bash RC, which configure the behavior of our bash environment, and the .ssh, which is contain the configuration of the SSH, like the private key, public key, or the host. And so these are .cache and .config and .local. They all have their special meanings. Usually can be override the system behavior. Like .local, you can put your fonts, like text fonts inside it, so that you can use instead of just using the system fonts. Okay, some of the more special file name is the dot and dot. These two. The dot is in fact the directory itself. So if let me show you here. Currently I'm in home TJW. If I cd dot, then it does nothing because I'm changing to the current directory. I'm not moving to anywhere. I'm just moving to here. I'm not moving to anywhere. So dot is just means the current directory. If I ls dot, I get to list the current directory. Same as doing these things, or same as doing these things, because the dot is currently home/tjw. Then how about dot? The dot is the parent directory. So currently I'm in home/tjw. So my parent directory is home. My parent directory is home. So I can cd dot to get to the parent directory. I'm using H here. So it is really clean. It just has dot and dot. Every directory has a dot and dot because the dot is itself and the dot is the parent directory. So even for the root, it still got a dot dot. So what is a dot dot? What is a parent directory of the root? We can check. It is itself. You can even see that the timestamp or like the size or everything is the same. But because every other folders have some, apparently they have a parent directory, so it makes sense to make things more consistent, so that the root still have a parent directory, but the parent directory is itself. So in fact, if by consider this sense, the file system is not a tree, because the root has a parent. So we got a loop. So it is not, by definition, it is not technically a tree. But they are similar enough. Okay, another useful but shorthand is the dash itself. Let me go to my home directory. cd dash means go back to the last directory. So let me make create some directory here. Let me go make directory like dir1 here. Then I change my directory to dir1 and see my full path to be home/ttw/dir1. I can change my directory to directory 2 by, one way to do that is home and directory 2, but I don't have to do that because I know my parent directory. The directory 2 is in my parent directory, so I can simply go to my parent directory and the subdirectory dir2 of my parent directory. So this means it. So why the dot even exists? It is because it not only allows you to access to your parent directory, by combining with other syntax, it can be very, very useful. So I can go to the directory 2. Then I can use cd dash here to go to directory 1 because I was coming from directory 1. So a lot of times you are switching between directory. Sometimes you just want to go to another directory to do some things and go back to the major or the main working directory. This happens a lot of time. So you can use this one shorthand to be, it's very convenient. And I can go back to directory 2 again and go back here using this guy. There are some more advanced command, like you can use pushd or popd, things like this one. And there are a lot of different ways to manipulate the navigation history, but they belong to the more advanced scope. I'm not going to cover right here, but there are other ways to memorize more directory, and you can navigate to a lot of those different places really quick. Just so you know, there are ways to do that, but just like I said, it is beyond the scope right here because we are only going to introduce more fundamental and the basic commands. And the other thing is I'm not that familiar with that, so I'm assure you that you can survive without those commands. Okay, so that's one thing. Just one more note that you can use, combine this dot together. This means we go to the parent of my parent. So in this case, I'm going to home. Let me go back and let me show you the directory. Because I'm in here, dir1, so I can go to the parents of my parents, which is the home directory. And of course, I can go to the parents of my parents of my parents. In this case, it's going to the root directory. So you can see I'm going to the root directory. Okay, so this is so much about the navigation, CD and LS. Just a side note that LS has a lot of different options. So let me go to a more rich directory. So what if I wish to list these files and not this one. So here. So we have a lot of different files here. So what if I wish to kind of list this file but sort them by the file size? List can do it. What if I wish to do that and sort them by the date, the date time here? It can do it. Else can do it. So one way to do that is to use a traditional way to read the menu. You can use Google or use built-in menu called the MAN. MAN is like the human man, the mailman, male human, but it is in fact the shorthand for menu. So I can use man ls to see the menu of the ls, and you can read through it and figure it out yourself. Or another way to do that is using info ls. You can get another type of menu. This is more like a GNU style, and the man is more like a Unix style menu. But both of them are just menus using different style or preference. You can also, a lot of commands allow you to like --help. Then you can find a simple version of the menu, or ls-h. In this case, it is not working. Sometimes -h refers to the help, but in this case, of course, we know it is corresponding to the human readability. We just introduced that options before. Sometimes you can use the question mark, but not here. I think it's more common to just use -help, and you got this simple version of things. However, as we probably hinted before, the most convenient and maybe modern way to do that is to use an AI. So let me just ask you, that's UI. For this kind of simple task, the AI is, I think it's quite reliable. However, in some case, it can provide some wrong answers. So use it with caution. But in this case, I'm pretty confident it will get me a correct answer. So how to ls files and sort by modified last modified time. Okay, so let me make it bigger. So you can see that you can use LT or LTR if you want it to be a reverse order. So I click the icon again and get it inside my terminal. And you can see that maybe I should just add an A here to have more files involved. So you can see that it is actually sorted in ascending, sorted ascending way. Okay, so that's about the ls. Now let's go to more commands, more common commands. So one of them is touch. Although you probably won't use this command often, but I'm introducing it right here because it is a really quick way to create a file. Just you may see that mkdir, that is a shorthand for make directory, can create a directory. So how do you create a regular file? You use this one, touch, like abcd. Then you see we got a new file called abcde, and this file contains nothing inside it. You can see the size of it is 0 because there's nothing inside. We just touch the file. It is really useful in many situations. So one thing you want to make sure you can actually create files inside a directory, because sometimes, although we can read the access rights to know that we probably has the we have an access, read access, so we can write access, so we can actually create a file. But sometimes it is more directly to just create a file and try it. And sometimes, even if you have the writing permission, you still cannot create a file because maybe the disk is full, it has no space left. So it will help you to quickly to address the issue. Okay, because if the disk is full, when you try to create something, it will show you an error message that it cannot be done. Or sometimes because you are working in a network or remote drive, so there has some network issues. So there comes time that you need to quickly create a file in a directory. And sometimes using this, it will trigger a watchdog or monitor, file monitor. Because sometimes you want to reload your server or something. You can just use this one to just have some change in this folder, to just make some change in this folder, and it will get things work. So anyway, it's just a tool and very easy, very simple to use. So it does not appear to be very useful at the first glance, but after you're familiar and when the times come, you'll find it maybe usable. Okay, other way to create files or to change file is like, one of them is mv. mv is to move files. So I can move abcde. You can see that I am hitting tab right here, so it can auto-complete in the bash, in this shell, because it knows the things that follows mv must be a file name. So I hit the tab, it will auto-complete these things. So let me move this abcde to another directory like dir1. Then it is done. It is not appear here. And when we go to dir1, we got abcde. We can move it to dir2. Then we can see the file. We can move it to a parent directory. Another common use of this mv command is to rename a file. Because if you are using the Windows, the DOS or CMD, you probably knowing that rename is a command. There is a command for renaming file and another command for moving files to another location. But in the Unix shell, mv does both. We can simply mv abcde into something like a rather long. I probably should not use the character only. Okay, so we got the file name. Okay, so how do we so we got the mv. So how do we to see the file, the contents in this file? One way to do that is using cat. Because there are nothing in it, so we see nothing. But you can see that I was using the tab to autocomplete the file name. This is particularly useful in this case because the file name is so long and so meaningless. So I just type the initial H and type the tab, and then so it kind of emphasizes the usefulness of the auto-completion because people use this all the time. Let me move this one into called abcde. So another way to create a file is using cat. Not only cat can show the contents of a file, it can also show the contents that you were typing in. So basically, if I give no argument of cat, it will go into a mode that is taking input. So I can do, let me do it again. Like, this is a pen. So you can see that when I type this is a pen, and when I hit enter, it shows this is a pen again. And when I type the other line, this is a book, and I hit the enter, the cat, it shows this is a book again. This is because cat is simply taking an input and showing it, redirect it into output. And if you don't give it any argument, the default input is your typing input, and the default output is the console itself, just the terminal, what you are seeing. And because the input of the terminal or the shell is buffered, which means that it only input to the into the program or the code or any executable only after I hit the enter. So that's why when I type this is a pen, enter, then it will show out everything that I just typed. But anyway, if that is too complicated, it doesn't really matter at this point. You just know that what cat do is taking an input and the output, redirect the input into another output. So if I keep typing, how do I stop this one? One way to do that is hit Ctrl C. Ctrl C can break the program, just like what I did. But the more proper way to do that, to end the input, is to hit Ctrl D. Ctrl D here. So in Unix, Ctrl D means end of the input, end of the file, end of the input. This is in the Linux or in the Unix or even in the Mac. Ctrl D means end of the input string. However, in Windows, the same thing should be Ctrl Z. Ctrl Z means the end of the string. But you should not type Ctrl Z in Linux if you're not familiar with what Ctrl Z does. We probably will go to that later in the class, but Ctrl Z has a different meaning. Okay, after we know that we can type something and print it on the screen by using cat. One way to do that is to use it to create a file. Let me create a file 1 here. So you can see that we have a greater than symbol right here. This in the shell, in a base Unix shell, this greater symbol means we redirect our output to this file. So instead of showing everything I type on the screen, this is a pen, enter. This is a book, enter. It will redirect the output into that file 1. So after I hit Ctrl D, you can see that we already create a file 1. And the size of file 1 is 29 bytes. So how do we see the contents of file 1? We can still use the cat file 1. So currently the file 1 is replacing the default input, that is the keyboard input. It replaces the keyboard input. So the cat will take the content of the file, or contents of the file 1, as its input. And the default output as the screen is the terminal, the console. The terminology is console. So it will show the content of the file 1 to the console. So you can see that it can show the content of file 1 to the console. Another way to do that is using this less sign, like the mathematical symbol, less symbol. Use this symbol. This means we redirect the content of file 1 as the cat input of cat. It works the same as before, like this one, cat file 1, because cat will take the file 1 as the input content. But in the shell, it will always use, when you use this symbol, the less symbol here, right here, it will always treat the files after this symbol as the input of the program. A more civilized way to see the content of file is using more file 1, or using less file 1. The reason that we need to use more or less is because they provide some control so that you can read the file page by page when the file is pretty large. Let me use the cat to create a rather big file. So when I cat file 1 to file 2, the file 2 will contain twice as many contents of file 1, because this is the first file 1 and this is the second file 1. I can do the file 2 into file 3. And also I can do, similarly I can do file 3 into file 4. So I already got some big files, but let's do it again. to file 5. Okay, so one tools that you can use to examine how many lines of this file is using WC, which means word count. Word count. WC file 5. You can see that we already get a file with 240 lines and 960 words and over 3,000 characters. I still think this is not large enough. Let me do it again. Let me make it 5 times larger to become file 6. And we use WC to see file 6. So you can see that as files times larger, it becomes 1,200 lines in this file. So if we use cat to see this file 6, we'll get really fast showing things. Although a lot of terminal support the scrolling, so we can scroll up and see the content. But a more civilized way to do that is using more file 6. So you can see it page by page. You can even do the search by using slash. So more is a standard tools in Linux. However, personally I use less a lot. There are some more modern newish tools, but less is still pretty good. We can use less to see it. File 6. Because not only you can go down, you can go up. You see, you can go down and go up. There are a lot of different shortkeys, but you can see the menu, kind of like the vim, but that is totally another topic. But one way to do that, one particularly interesting feature is to do the search by pressing the key slash and say book. It will find out all the books it finds, and by pressing N, you will because it has too many repetitions. So, but by pressing the key N, you can go through it to the next one, next book and next book and next one. I can go to the pen here and search through the next or previous one if you press the P buttons to do a lot of different ways to navigate the files. So this one is a pretty good way to see the things. Let me go to the SRC and to find some files here. So for example, if I'm trying to do, what I'm trying to do is to, let me go to the SRC and see things. Let me just show the CLI PY files. So you can see that I can go to see to find if there's print. Yes, there is print. And I was using the key G. It will go to the top, and I press N. It will go to the next print and the next print. So if I want to find the ADD, you can see that it can press by pressing N. It will search through the document, which is pretty good. There are other tools to show things, like I think Batcat is one of them. Let me install it. This command is used to install things in Ubuntu or in Debian. So apt is the default package manager in Ubuntu traditionally. Okay, so one of the modern tools that I'm going to introduce is BatCat. Okay. So it is a replacement of the cat, so that you can have a color highlighting, syntax highlighting for files, especially for the code, like a Python code or C++ code, or maybe JSON. So it is a replacement of cat or less or more, and so that you can see things more in a more pleasant way and more clearly, because it has syntax highlighting. So this is one of the modern tools that replace the traditional one, but it's still good that you can knowing the traditional or more standard tools before, and so that you can appreciate these new tools and knowing what kind of the issues that these new tools is trying to solve. But another modern tools that can replace the LS is like EXA. So you can see that it is more colorful. I can ask the Copilot to like how to show the color name for or header. We should show the header using EXA. In fact, the tools I'm using is EZA, but it's compatible with EXA. It is a replacement of LS, and it can have more prettier output than the standard LS. So, for example, the Copilot just told me that I can use the option header, so that when see things, it will has a header. So remember that we were explaining the meanings of each of these things. The EXA provides an option called header. It shows, okay, these are access permissions, and this is a size, and this is a user, and this is a date modified, and this is a name. It provides more clear clarity of the meaning of what the list of the file. And okay, let me stop the video right there. So you can see the full video on YouTube, and I'm probably going to make a bit more, because I do think that a lot of tools is worth introducing, and I list a lot of tools on the course webpage, so you can check them out. There are a list that I think are most useful tools in when you use the terminal. So let's go back to the more concept part, so that I wish to explain, because there are just two main tools. The concept is more fundamental and important here. So before we started the video, we were introducing different type of shells, including Bash, ZSH, Fish. Personally, I use all these shells in different systems. A lot of time I'm using ZSH instead of Bash, but for some new system, because I use a lot of different systems, when I work with other companies, help other companies, they usually offer a new cloud machine on each project. So for that project, I probably will open a new machine there. So I didn't bother to reset my ZSH environment or Fish environment. I'm using Bash instead. Plus, Bash is more standard, so a lot of script is and the command is compatible with Bash. So I still use Bash a lot. But for my personal computer that I'm using, especially for Linux environment, I used to use ZSH as much. I mean, most frequently. So mostly I'm using ZSH because ZSH is a little bit smarter and a little bit prettier. So when you work a lot on this environment, it makes you a lot happier. And also, it can track your typing command history more easier. Because I think that is the most used functionality for ZSH is to complete and search your previous command, because we tend to repeat our command very often. So that I think is one of the most selling point of ZSH. And also I use Fish a lot. Fish is kind of like ZSH, but it breaks more the compatibility with traditional shells like Bash. The syntax is totally different, even with the variable or quote string. They're totally different. But I'm trying to use Fish on several systems of my own. The sell point is user-friendly. And there's a terminology called the POSIX, P-O-S-I-X, which means that a system is Unix compatible, because Unix is a track. Although we call all this kind of system Unix, or maybe in nowadays people are more familiar with Linux, but Unix is an umbrella name of the system that kind of looks like Linux, that has a command line terminal in Bash, using Bash like system, and has a X terminal like GUI system like KDE or ground environment, desktop environment. That's called Unix. But Unix is a trademark, so people cannot actually call a system Unix unless I forget which company owns the trademark, but it requires a certification for that company. Otherwise, you are going to be sued. So you cannot just simply call yourself Unix. So another name is come up, like Unix-like system. That's okay. That's something similar to Unix. Also, another term to replace this concept is POSIX. POSIX has some regulations and the rules about what kind of tools is required in your system. So if you are certified as a POSIX, P-O-S-I-X system, then it's sort of like you got a certification of is a Unix system, sort of Unix system. However, you can search the web for POSIX, POSIX, and see a lot of systems. So a lot of systems didn't file the application to be certified, and the rules and the regulation of the POSIX, the requirements of the POSIX is not entirely practical to the use. A lot of tools that required by a POSIX is seldom or never rarely used by people. So Bash and Linux is POSIX enough. However, the ZSH and I think the ZSH breaks a little bit, and the Fish break a lot. So some of the script cannot be run on under ZSH, but probably required by some system certification requirement, like I believe POSIX. I'm not entirely sure, but just so you know, there are some there's something called POSIX to certify a system is Linux, a Unix or not. So even I think Windows NT or something is also a POSIX system, because it provides enough tools that can pass the requirements of the POSIX. So it's not an absolute standard for the feeling of a true Unix system, but there is a thing. And ZSH, I think ZSH breaks, and Fish definitely breaks the POSIX. for cannot running some script, but anyway, people use them a lot. Okay, there's also we introduced the SH and CSH and TCSH. So on Windows, that's a little bit more interesting because back to the days, people sometimes call the terminal or the command line interface, they call it DOS. At least in Taiwan, I know people call, okay, you are using DOS because a lot of people work through the time period that for the text, their first text user interface is the DOS. And after Microsoft introduced the Windows system, starting from basically they will have something like Windows 1.0 and Windows 286, Windows 386. But the first Windows that getting really popular should be, I think it's Windows 3.0, Windows 3.1. A lot of people access to this graphic user interface start from Windows. So people, at least in Taiwan, I think, people calling the user interface as Windows, graphical user interface, GUI, as Windows, and call the text command line interface as DOS. So the shell in the DOS system is actually called command.com, which is a format of executable binary in DOS system. So this one, people still call it DOS or command, but a successor of a command is CFD, which is pretty similar to a command but running in Windows. Another Windows has a good shell system, which is called the PowerShell, but it's kind of interesting. I believe the author of at least one of the authors of PowerShell give the whole stories about it probably several months ago or 1 year or 2 years ago. I forgot, but the story behind it is pretty interesting. But I still believe some people like it, some people doesn't. To my knowledge, PowerShell is a good shell, and it has more modern design concern. So the command is more meaningful, readable to people. Like what we just see that in Unix, ls is listing a directory, and you use mv instead of move, and a lot of command is just short-handed. It is in favor of fast typing than readability. But in PowerShell, a lot of command has a full English word inside it, and combine this long word. It is more readable. So I think it's more like a modern design because not because people typing faster, it's because we have a better autocomplete mechanism inside the Windows terminal interface. But we are not going, in this course, when we're talking about the shell, we are not going to talk about too much about PowerShell or CMD. But they share some similar ideas and concept with Unix shell, and PowerShell integrate with the Windows system better. So it is better integrated with the clipboard or other more like object other than just simply the text string. But for Unix, the shell is work purely on communicate to each other. The program in the shell communicate to each other, mostly based using the text string. Everything is a text string. I just want to note that PowerShell is available on Linux too. I don't know how many people use it, but there is support can be run on Linux. Okay, so now let me clarify a few concepts related to the DOS or terminal or command line interface. So first of all, we need a terminal emulator. why does we call it an emulator? Because once upon a time, there is actually something called the text terminal. A terminal is kind of like the computer monitor you are seeing, a computer monitor with a keyboard, perhaps with a mouse, but mouse was invented pretty late and popularized pretty late. Perhaps it is popularized more popular after like 1990s. But before that, a lot of computer only has keyboard and the terminal. It looks and feels like a computer, but a terminal connected to a remote machine. A terminal doesn't necessary to be a text interface. There are something called X terminal, which is like the GUI interface that you see on the Linux system. It's just uglier, but people design X11 or X Windows system. There was some predecessors, but X is the one that being popular and people use. Now there's a successor that replaced the X in most Linux systems called Wayland. That's a different design, but the X system is designed that has a client and server architecture in mind. So that is also a terminal. So terminal is not entirely restricted to the concept of text interface, but people use a lot of back to the GUI being popularized. Most of the terminals are still text-based. There are two kinds of text-based terminal. One is called the dumb terminal. Dumb, like a stupid, means dumb terminal, which means when we connect the terminal to the remote machine, or maybe the room maybe just resident inside your room, but it connected with a serial line. So it transmit the text to your terminal, your current terminal machine, and it doesn't remember anything. So it doesn't have a memory inside it. It just print out the things. So it shows things one by one. It shows the line one by one. It's called the dumb terminal. Another terminal is pretty. Yeah, so some more advanced architectures that the terminal itself has some memory, so you can do a full screen things. For a dumb terminal, you can just do this line by line. Okay, so because there was some physically exists real terminal, so the terminals that we are using in a graphical user interface system like Windows or X terminal or something, we call it a terminal emulator that emulate the behavior of a real terminals and standards when they are physically exist. So a lot of terminal has a name called the VT100, VT200. They actually have some models that has the same name. Some of them has a name called ANSI, ANSI, which is like America's national standard terminal. So it is for more simple and simplified protocol that we can commute with the remote machine and control our screen. So there are different protocol for the terminal, and your terminal emulator can simulate and do the emulations on these different protocols. Currently, you don't worry too much about setting the terminal type, unless you are going to do something really weird or on the edge, usually you don't need to worry about it because currently most of the terminal are like 50-100 compatible, and for the color things, it's more comparable to the later Xterm. Xterm is one of the terminal emulator that is very popular back to the 90s on the X Windows, but currently people use other terminals emulators more. So they design a protocol specifically for like for X terminal. So there are different protocol, but currently most we are not using different protocol. So it kind of sort of standardized, so you don't need to worry about what protocol that terminal protocols you are using. But there is a setting that you can change to a different type of different terminal when you need it. So the terminal emulator is a bridge between the user interface. So you have a fake text environment and connect to the shell, like a bash or the command things. So in Linux, it used to have a text mode. When you press Ctrl, Alt, and F1, or maybe Alt, F1, F2, F3, you can switch to a different, I think it's called a virtual console. So some of looks like a text mode, but in nowadays they are not in real text mode. They are actually in some graphic mode that can show a text. But back to, I think at least I'm pretty comfortable, back to 90s, they are actually using the real text mode. So that in that mode, you can only use text on it. But if you are install a Linux on a new computer, most likely they are actually using a graphic mode, and so that the resolution, because the monitor has higher resolution, but so you can get a text mode, but that text mode is technically on a graphic mode, so you cannot actually getting something really text. But the virtual console is the closest thing and the easiest thing you can get to get a feeling of what the real terminal like. But most of the time, like what I'm doing right now, I'm using a graphic user interface, so I'm using a terminal emulator instead. There are some popular terminal emulators like GNOME, Console, Item 2 for Mac OS, Windows Terminal, like I'm using. There are still more. For example, let me put this one. This one is Windows Terminal. I like Console a lot, but because I didn't use WSL on this computer much, so apparently I don't have one. However, I'm not sure I'm installed Xterm. Not yet. Okay, but I think I have installed the Warp. I just installed the Warp terminal, which is very interesting. This one is the Term. It's also another popular terminal application, and it's portable on different platforms like Mac OS, Linux, and Windows. So you can see the Western. A lot of people like it. But what I wish to introduce and let you see is a terminal called the Warp Terminal, which is a AI-powered terminal, kind of like the Visual Studio Code terminal we just showed you before. But this one is dedicated to application as a terminal. Unlike Visual Studio Code is in fact editor, an IDE or editor, but this one is totally AI-powered terminal. So it encourages you to type nature language to instead of using command directly. For example, if I want to list files in list directory, I simply type list files in this directory and sort them by size. It will do so. I can simply click enter and it will run the result to me. It seems a little bit too slow, but it do the work. Also, I can has a more complicated usage, like list the process. The process is a program that is running on your computer that use most memory. So this is a more advanced IT command, but you can see that it uses the PS and sort it by memory and get here. So I got a node cost some memory in this Windows subsystem Linux. You can see that it is already a more complicated command line. I admit that this is something that I don't remember. So even with my experience, I'm not saying I have that. I'm not expert on command line things. There are some wizards really doing things really well and can do something really magical. I'm not. So this is already beyond my comfortable zone. So like I don't remember the name like COMM or percentage memory and this sort negative memory things. I do know the head command. We just I probably cut the video, but I introduced it a little bit later in the video. So it can be very convenient. So this one is a most hard terminal that is used, that people talking about. However, I didn't use it much, so I didn't use it as tools for teaching. That's why I use VS Code instead. Because it used to be on Mac OS only application. Now it can be used on Linux too. The Windows version is still has a waiting list. I've joined the waiting list, but it doesn't have a Windows version. So right now I'm running a Linux version using the Windows subsystem Linux. So this is not a native Windows version, but I think this one is quite useful. But I don't use it a lot because I am not working on terminal that much. I still do use it every day, but I don't consider I'm an IT man, IT guy. So use this. I will show you a lot of workflow that I use, but I do not consider I'm using it intensely. So and when I use it, I'm using the command that I already know. So I don't use it much. But as a learning tools, it might be helpful for you. Also, let me go back to the Visual Studio Code here. So we have already introduced this guy and show you how to like using the Copilot chat. Another way to use it is by hitting the shortcut Control-I here. That you can ask using the AI in a more immersive way or more integrated way, or maybe I say more inline way, because when you use the chat, saying there's a separate panel on the left side, so it still feels like you are dealing with two things. It looks more like a document side by side, but sometimes you just try to have more work terminal like experience, then you can use this thing. So one thing to do that is to explain. You can do, I'm doing the same thing. List the process. List the top 10 process that use most memory. So I can hit run right here, and it will run the command and get the process. Okay, you can see that it can still run here. And another way to use that is to expand the command, some command, like what is ls. So it can replace the main and the info as a menu for you, a document for you. Okay, so you can see it explain what it is. Can you give? Let me try it. I haven't used it before. Can you more detail? So you can also use it on the sidebar. It will might be. If you put press this icon or use the hotkey Control Alt I, not just Control I, Control Alt I, you can get the sidebar, the chatting sidebar. So you can ask it to explain things in more detail, I believe. Okay, you can see that it explains more about the usage and the situation about it. Okay, so that is terminal emulator. So let me go back to the slide. So so now let me explain some concepts. So first of all, Linux. Linux is the operating system. The most strictly meaning for it is referred to its kernel. So the kernel is a software that communicates with the hardware and the user space things. So every program you are writing or every tools you are using is communicate with the operating system. So you only have one operating system to in charge of every resource management on your PC and communicate the hardware and your software. So that's a Linux for. But we also refer to Linux to the Linux distribution like Ubuntu or Debian or other Linux distributions. So sometimes we are considered as a collection of the tools that are available in Linux and with its kernel. A lot of tools are coming from a project called GNU, GNU. GNU is a project to develop a lot of tools that can replace the property tools in Unix, because at the beginning, Unix, like we say, it is a trademark and there's a company behind it. A company owns it. So you have to buy things, buy the system, buy the software. But in the free software movement, people believe that we can charge the software that we own. We can modify it. We should have the right to modify it. So in order to modify, the source need to be provided. So because we have bought it, we have the right to modify it. Like when we bought a car, we are mostly feel free to change some decorate or maybe change some parts in the car without any issues. But in the case of software, it is difficult to do so because if we don't have the source code, it is very difficult to modify the software. So they believe that people should have the right to modify the software that you own, no matter it's free or not. If you buy it, you should get the source code so that you can modify it. So that's the point for the free software movement. But right now, you may know more about the open source. They are sort of the same thing, refer to the same thing. Listen, I believe like after 2010 or so, open source or free software can be used exchangeably, and people use open source more, and people less use the terminology free software less, because maybe free software sort of makes you think the software is free in the sense of price. It doesn't cost money, but instead the free in the phrase free software meaning the liberty, meaning the freedom, instead of meaning really cheap price or cost nothing. It doesn't mean cost nothing, it just means freedom. So it will make some confusion. So probably that's the reason people promote the open source more. It's sort of more accurate. But back to 90s, they are referring to the two different approach to a very similar things. That is, provide the source code that people can see and modify and contribute, or those kind of things. So GNU is a project for free software foundation, and it recreate a lot of tools that originally exist in Unix and more. So like Emacs editor, EMACS, is one of the flagship project in Free Software Foundation, at least at the beginning. But later on, it has been forked into different versions. That's another story. And also GCC, if you are using a compiler called GCC compiler, it actually called the GNU compiler collection. Originally, CC means C compiler, because there is a compiler in the Unix system called the CC, C compiler. So later on, the GNU branded it compiler to be GCC. So people may assume it to be the GNU C compiler. However, it grows up, and not only it compiles C, it also compiles other language. For example, like C++, or maybe other I don't know, a lot of different language that is supported. Like Zig, I believe, has a backend, and because it becomes a more complicated, more complete project, so it has a compiler backend framework. You can design your own language based up on this framework, kind of like a LLVM. So it changing the name. At least it is known as the GNU compiler collection. Okay, so there are a lot of tools, and Linux use them. So once upon a time, the one of the creator of the free software or GNU project complains that the Linux should call the GNU Linux instead, because they use a lot of GNU tools. So you can see a lot of place refer Linux as GNU/Linux, because it is a Linux and it has a lot of tools come from the GNU. So the shell is a bash or ZSH or CSH, which we were referring to. It is just a kind of like an interpret language interface, but a lot of tools like what we use, like maybe top or other WC or something like that are actually some program written separately. So these things are command line tools. Even Python is a command line tool. It's a command line tool. So for example, let me go to the shell here. We don't need this anymore. So we have several things like ls and wc, like file 1 you can see, or maybe we have a cat. So some of them are actually built into the shell itself. So if we have different shell like zsh, bash, some of the command that may be actually command, but some of them might be tools that is using separately. So how do you find out what does this command come from? You can use which wc to see. Okay, so wc is actually a program that on this path, user bin path. So we can actually ls it here. Or sometimes we do this thing. That is in bash that you can do which wc. You can see the backtick here. This means whatever it returns will substitute the output of this command to the command line and ls it. So you can see, and maybe I can make it more detailed. So you can see it is a file that is of course executable by everybody and owned by root. Size is 43 kilobytes. So how about ls? You can see that ls is at user bin. So if you change it to another thing, it will, if you change your environment, so it could have different meaning if this ls is pointed out to other program. And we can also see that the cat, okay, is also a program in user bin. So you got the idea that a lot of tools are resident in the user bin path. However, things like echo, echo is still in some shell, the echo or in like the ls are built in. Sometimes they are built in, like a command. Maybe I'm not sure. Help? Okay, there's no help. Oh, there's a help. But you can see that when I get which help, it doesn't have, because help is a command. Help is a command. Or you can see like Python. Like it's really useful to see what is I don't have Python right here. Okay. Do I have a conda? Okay, I really don't have much much software installed right here. But just let me show you that maybe I can use it on another terminal right here. Here. Right there. Okay. So in here, it is on a MSY2 system on Windows. So it is not on a Linux, but using a bash as its interface. And I have already installed the conda on it. So you can see that. Okay, it has a conda, but just running. I'm using Mamba mostly because it is much faster. But anyway, the thing is, if you have different install of Python, chances are you don't know which Python you are using, and maybe you are assuming that you are using a Python from the environment, like a conda environment, but it is still possible the Python that you are using point out to some other files. So I use the command which Python to see which Python I'm using. You can see that it is in a mini-forge Python because I'm using in a base conda environment. But if I am, I believe Python. let me list my. So member conda are all command line tools. So I list my environment. Oh yeah. So py311 activate. No? Oh, okay. Oh, that's really troubling. Oh, okay. I believe I already. Why is this happening? I'm not sure, but let me try it again. Okay, this is supposed to work like this one. I'm not sure what happened. For here, I'm switching to another environment, so I can use the command which py311, not Python, to see. Okay, I use the right Python version under the environment right here. Because sometimes you are using Python 3 as a command line like this one. So a common mistake is that you're typing Python 3, but in fact you should use in Python instead. And Python 3 is pointing out to the system installation of your Python in Linux. It is possible that is the case. So you still feel trouble like, okay, I have already installed my package, but why does the Python does not import this package? I still got an import error. The module does not found. This is because perhaps you are installing the module with another version of Python, but running the Python code in another. So you can check like this one, pip. Okay, so I got my pip right here. This, if I'm installing it with pip, then I got my pip script here. And I can check the content of it. But in here, the pip is just in your Linux, the pip should be a human readable script, a shell script. But here it is just an executable file, so you cannot read it. But the idea is that you can check inside the pip and see what happened. But sometimes it might be difficult for beginners, so people are using. That's why people are using in a lot of documentation. People are using Python m -m pip instead of calling pip itself, like install something like this one. Instead of using pip, install pip, because in this case you are going to make sure that your pip using the same Python version, because you already know it's transparent, the Python version you are using. You can use this to check out which Python you are actually using. If I'm switching to work, then the Python version changed to another. So that's the secret. You can see that it work, and this is py311. So that's the secret of or the mechanism behind how Conda environment or other like PyInf or other work. It changed the Python that you are using in your environment. But if you are really curious, you may ask why. How does it change? How does it do? What does it do to change the Python that is used by the shell? Is there an API that told the shell to use which Python or which command? In fact, there is. It is called the environment variable. Let me go back to. Let me list all environment variables. Okay, so let me do it. Run. So you can see that we have a lot of environment variables here, like shell is being bash, and our color terminal is true color. And because this is WS2, so it has a variable tells that whether we should enable the graphic user interface apps. Also, there are a lot of different things, like how do I control the colors when we using the ls command. It is defined right here. So if you change this one, it will change. So the environment variable is something used by all the program. It is not because if you are using bash, the environment variable is not only used by bash itself. It can be accessed by all of the different programs, like your Python programs, your other things. If you are using Python, not here. If you import OS, there's os.env. os.environ, it will get the same thing. You can print it out to get the same thing. So it can be accessed by everything. So it serves as a kind of like a system configuration. In Windows, there are also has also in DOS, it also has environment variables, and they work pretty much the same, with slightly different variations, but they work pretty much the same. So every problem can access to this environment variables and pick some of the environment variables to change their behavior. So if, for example, some of the useful environment is the path. Show the okay, so let me run it. You can see that there's a $sign in front of PATH. So that is how you access to this these things. You can also like ls $sign PATH, but because we don't have this string as a file, so it pretty much does nothing. But if I use echo is like a print. In case I haven't introduced in the video yet, echo is like a print. So I just print out this variable. You can put this variable inside a double quote. It will work. But if you put it in a single quote, it will print the $sign path. So the single quote and the double quote are different in Bash. Okay, so let's see these things. This is a list of paths so that we can search in that path to looking for command line tools. Or to looking for command line tools. So for example, here. Let me. So you can see the environment path is at the first place. So there are no magic behind it. It's pretty straightforward. When you set up the environment, I mean the conda environment, it will change the order of the environment. It will change the content of the environment path, environment variable path. So put the conda environment directly at the very beginning, so that when the bash or any other shells search for the command, it will search this guy first. So because we have a Python right here, it will call the Python inside this folder. So if I change my environment into another one, let me just and see the path. So you can see the first entries in the path is changed from work to py311. And you may notice that the paths are separated by the comma. Okay. So that's environment. Another useful environment is the language. I myself use export instead of print-in to see the variable that has been exported. You can set the variables like a export. Then we get a new environment variable a right here, and I can do get this variable. So it uses a lot to do the thing automatic. You simply set the environment variable, and everything should be working according to these variables. And if I enter another shell like the I don't think I have the VSH. Let me install it. By the way, sudo means let me have the super user privilege, also, which is very useful. And Windows got a sudo recently. Okay, so let me have the VSH. Okay. Okay, so I'm into a VSH. I can still like echo to get this, because this variable is inherited and shared by all the process spawned by this process. So you can share all these things. Okay, some of the useful variables are like language. So you can see that I'm not using a Chinese language in the system. If you change this language, it will change the things like language used in the menu or in other things, or in your other applications. If you use a program like say top, like htop, like this one, and you see something like a foreign language that you cannot, you don't understand, then maybe you are setting the language wrong. At one system, at least I remember, when I installed the Linux, I was setting the language to become ES, ES.UTF-8, of course, instead of EN, because I was trying to setting up the system to use English at the beginning, but instead I use in ES. I believe it's one of the Raspberry Pi system also, because the screen is so small. I don't remember. But I assume that I set the language to be ES instead of EN, so everything becomes Spanish. It took me a while to change everything to go to correct things, because they use a special protocol to decide language in the, I believe it's Raspberry Pi or some distribution of Raspberry Pi Linux. But in the shell, at least in the current shell, the only thing matter is the len, or like LC type. Maybe I should just export. I use export to grep LC. It doesn't have LC, it has LAN here. Okay, so it only has language. So if I change a language here and I install the corresponding language translated files, every message is going to be in that language. But I don't believe I install too many languages inside this system, so I'm not going to try it. I'm just saying that a lot of environment variables that are very useful and can change the behavior of the program. Another variables that you may encounter in really soon is the variables that affect CUDA behavior. Like one of them is a feasible CUDA device. Like this one. You can use this one to control the behavior of the program that seeing which suppose you have 3 GPU card, graphic card, NVIDIA graphic card on your machine. You wish the first program to use the first one and the second to use the second one. You can use this to control which GPU is using by which program. So one way to use this environment variable is like this way. So if I'm just using echo k, it doesn't show anything because k is not set yet. I can put it right here. You can see that there's nothing between 2x. However, I can do a thing like this. I can use a syntax like this one. K equals to 33333 and echo this guy. Let me write a simple program. Okay. It tells that we use sh to run this program. Echo I can change mode. You can see right now it is not executable. So I can change the mode to so that everyone can execute a.sh. It shows nothing, but if I assume I set, it will pass these variables into the program here, a.sh. So it will get change the behavior of this program. So in the case that you wish a program to only can only see certain part of the GPU, you can use this environment variable and use like this way to change the behavior of this program temporarily. So that is very useful, and you can combine many things together. So suppose that I do echo so I can do things like this one, and hello is equal to ABCDEFG and change the behavior. Also, you can put the argument after the a.sh. Okay, let me do a simple trick here. Because I have already called the VIM before. So one trick to do is to use the exclamation mark here and like VIM or V is probably enough, and calling the previous command that I am using that start with the initial as V. So I can quickly jump to the command that I have been using. So another thing to a spatial is like this one. $1, which means the first argument after this script. So I can do like u. So you can see that. Of course, the second one is $2 and $3, $4, etc. There are some more advanced usage. If you are interested, you can look into the shell script programming. You can find a lot of information about it. Okay. A lot of things that you can do is like using PS to see a space PSX to see a lot of process that you are running, and history to see a command that you were using. So you can, if you forget what you have done, you can use the history and see the transcript that you are working with the command. And also using PS or PS, I'm using PS, always using PSX, I can see what process are running. It is very useful if that when you are using some process are sort of keep running and does not stop, and you wish it to stop, then you can use it to find out. Another useful tool is htop or top. It helps you to see the process that is running on your system, and you can even this is a text terminal, the mouse is still working. So you can, like I'm typing a CPU here, so it is sorted by the CPU and sorted by the memory. So if some process is occupying the GPU or like memory or CPU and make your system slow, you can kill this guy. Let me do it again. So, okay, I'm doing this right here, and if I select this one is darker, that I am not trying to use it. Let me just find out the one use most memory. It is VS Code. So you can use the functional key right here to kill this process, like F9, or you can use command line like kill. Like you can see there's ID right here. For example, this one is 209582. So I can actually kill this process by giving I'm not ready to kill it. So I'm just typing a random number. It will kill it if it is still kind of working. If it is still not responding, you use a super kill. Kill is actually sending a signal to it. So this signal is intercepted, the signal number 9 intercepted by the operating system to actually kill this process. So you can use this one to automatically kill the process you wish to kill, to free your memory, to free your CPU. If this still doesn't work, then you are in a deep trouble. You are encounter something like zombie or other system lock or any things. But most of the time, this one should just do a trick. Okay, so if this one doesn't work, you know you are in a trouble. Okay, so finally, let me there are a lot of tools. I'm not going to introduce the tools one by one. You can see the list on the course website and ask the Colab pilot. Copilot, like what they do. And I will have some videos to introduce them one by one casually. But right now I'm going to introduce one of the important concepts that people doesn't use it often, but it's really useful. That is the job control in the shell. So for example, I have a vim right here. I can press the key Control Z. Not here. Okay. Let me just write a. I don't have a Python right here, right? I can like write a script that I make more specified, like share script. Okay, while true. Okay, I remember it. I know it, but I didn't just kind of has a block. I know that. I know for while that, but because I'm talking to, so I kind of just temporarily forget what it is. So I'm just writing this program to like while do something. Let me echo. And sleep for 1 second. Okay, so it does do the same thing. I didn't ask him to sleep, but okay. I guess people always do this and sleep for a while. So if I run this guy, it will running forever. So what if I want to kind of suspend this guy in the background and doing another thing? I just want to check some like, okay, how many files, what is the size of ASH, or I want to show people the content of a.sh. I do the thing like Control Z. I press the key Control Z here, and the program just stopped. Let me do it again, and I can use the jobs command to see that there's one stopped application. I can run another one. Actually, I want to modify the a.sh a little bit so that I can give it like this one. Like, okay. So this one becomes you. And I can stop it here. And you can see that I have two programs stopped. Now I can make one of them back to alive, like FG1. So the first one stopped working. Started to restart it, and it did not restart. It continued to work. It continued to work, and I can stop it again. In fact, I can put it into background, so it is running. You can see that it is running, but I still have the control to the input, so I can still do the ls, and it is running parallelly in the background. And I can still see the jobs here. So one is running in the background. You can see the end symbol right here because it is running in the background. And the first one, the second one is stopped. If I put FG means foreground for the second one is keep running. So both of them are running. You can see that the in one line and the you in another one. I can pause the second one and running another a.sh. Okay, it kind of annoying. So let me show you I'm running the third one. So I'm running the third one and I make it stop. So right now you can see that we have three jobs in the background suspended. I can make all of them running FG1, FG2, FG3. So all of them are okay. I should not use FG. I should use BG1, BG2, BG3. And you can see the jobs, all of them are currently running in the background. So in that way, even if you only have one terminal, you can run a lot of different programs at once, sort of like multi-threading. But actually, they are not multi-threading; they are multi-processing, because each of the program lives in a process. Okay, so there are a lot of different useful programs which we probably will introduce them in the third week, and just look into my YouTube channel. You will see I'm going to casually introduce some of them because there are just too many, and I do really feel excited about some of the usage of some of the program. Like I like Tmux. Tmux is a really good tool, and I use curl, CURL, wget a lot, and if user, and just a lot of things that are really useful. And there are also a lot of tricks in SSH. So some of them are going to introduce in the third week that is entitled with the name Docker. But Docker is also a broad concept that is not going to be introduced in just one week. But I'm going to introduce the basics. So instead, I'm adding some materials about the more advanced tools like SSH, because they are sort of related, especially for the networking part. A lot of people confused by the networking of Docker and SSH tunneling. So I'm going to do that later. But there are still tons of tools that cannot be covered in this week and in the third week. So we are going to so that's why I want to record a series of videos that talking about these tools casually. But also next week we are going to have a very useful and interesting topic. We are going to introduce the Git. So first of all, we are going to use the Git a little bit for some basic operations, but our main focus is going to be on the fundamental concept of the Git, and it is related to our homework. So see you next week.